Well, thanks everyone for joining us again. This presentation is about measures we can take at fence ends and at gaps in the fence for access roads, and also about jump outs. This is one of the things that we were able to get a head start on, at least on one of our study sites, when we have some actual results to share. It's important, though, that I recognize all the people and organizations involved. It's quite a complicated setup, as is evident from the names on the left-hand side of this slide. So what do we know? We know that when we have wildlife fences, typically in combination with underpasses, overpasses, we have to start and stop the fence at some place. It is always good practice to do that in a location where we do not have a concentration of collisions, where we do not have a concentration of wildlife approaching and crossing the highway. Nonetheless, there's always a risk that at fence ends, animals will get in between the fences and enter the fenced road corridor. This is not what we want. In some cases, wildlife guards, similar to cattle guards, have been implemented in the travel lanes of the main highway, as is shown in the image on the upper right. And in other cases, we have to deal with access roads that may also have wildlife guards. Now, what do we know about the effectiveness of these wildlife guards in keeping wildlife out of the road corridor? This graph relates to a specific design that we tested here in Montana. The design is modified bridge grade material, picture on the right. And if we first focus on the graph, the two species on the left-hand side, it's mule deer and white-tailed deer. The vertical axis is the permeability of these wildlife guards in allowing animals to access the road. We want this permeability to be very low, because if they do access the road, it is bad. This is where they can be hit by traffic. So these wildlife guards, the specific design shown on the right-hand side, has a very low permeability for mule deer and white-tailed deer, even though we have, very good sample size. So we feel pretty good about this wildlife guard design being a very substantial barrier to ungulates. Now, the species group on the right-hand side, these are species with paws: black bears, coyotes, mountain lions, bobcats, raccoons. And what we see here is much higher permeability. So whereas this design works good for ungulates, it does not work very well for species with paws, especially if we have large species that are concerned for human safety, and we have relatively rare species that are a particular conservation concern. We still do not want those animals to enter the road corridor where they may be hit. This is where we enter our project. This table on the horizontal axis has traffic speed, starting on the left-hand side from low to medium to high on the right-hand side. And on the vertical axis, we have the traffic volume. And in the different cells that are populated, we basically have different study sites with different types of electrified barriers to help species with paws and help them keep them from entering the fenced right-of-way. So in bold font in this table, there's study locations, and I'll go through the status of the study at the different study locations. The first one is Thompson Falls in Montana, in western Montana. This is a two-lane highway, about 2,000 vehicles a day, posted speed limit 55 miles an hour. So it's a solution at the fence end that is suited for relatively high traffic volume and high traffic speed. What we have here is a road section that is fenced to keep bighorn sheep out of the road corridor, keep them from being hit. There's one underpass. There's several access points along the highway with wildlife guards. And on the two fence ends, there's metal strips embedded in concrete, and these are electrified. A camera shown on the upper right here was installed at the end of September, monitoring wildlife that approaches the west side of this fenced road corridor. The east side location requires an additional pole specifically for the camera, and that had to be permitted. We have obtained the permit, and I'm now ordering the material, as it has to be a breakaway post. It also has to be pretty tall because of vandalism and theft potential. The second study site is also relatively high traffic volume, but a little bit of lower traffic speed at 4 different locations in Canada. 2 were existing wildlife guards that have been electrified, and 2 new ones were installed just a few months ago. All but one of these locations now has a camera and also has a 2-meter line marked in front of the electrified barriers. By the way, this is also the case in Thompson Falls and any of the other locations that we evaluate. It is a way to standardize the barrier effect of these electrified barriers. Animals that enter the zone within 2 meters of the barrier are evaluated for their behavior. Do they cross? Do they not cross? And this way we can compare the effectiveness across the different sites and the different types of measures. Highway 93, this is not actually part of this project, but it's very much related. This is why I included it. There are 2 locations proposed, as is shown on the upper right. It's that the Wildlife Guard modified bridge grade material. We know that they are a very substantial barrier to ungulates, but not to species with paws. But since it's so related to what we're doing for your project here, I will keep you updated as well. The proposal is in the final stage and will hopefully be approved by the Montana Department of Transportation at the end of this week. I'm not sure when we will be able to install cameras, as winter is about to hit here and the soil will freeze. Nonetheless, I'll keep you updated. The final study location is a melon farm, and this is something very good. It was very fortuitous that we were able to connect with other organizations and hit the ground running as soon as our paperwork was signed with Nevada. We basically have had cameras operational at electrified barriers since June. And I'll explain a little bit more detail and also some results in the coming slides. What we have here is an area on the Flathead Indian Reservation, just south of the National Bison Range. And this is a melon patch. The farmer has been growing melons here for years. And these melons are also eaten by wildlife, specifically black bears. The farmer has had days during the season when the melons were on, where he would arrive at the farm and would be 6 or 7 bears eating in that patch. So you can imagine there was substantial commercial loss. The NGO, People and Carnivores, was involved and built an electric fence around the melon patch. Our role from the research project was to supply the gates that have been electrified. Now, compared to the other study locations that I just mentioned, this is extremely low traffic volume, very low speed, one landowner, and we are able to investigate a much lower cost solution. Much simpler, of course, but since many road sections in multifunctional landscapes have access needs to agricultural fields, it is important to see if we can have low-cost solutions that are effective in keeping animals, specifically species with paws, out of the fenced right-of-way. Now, the electric fence and the gates have very high voltage, but it's the same as any electric fence for cattle that we have been working with for many decades in the agricultural industry. Now, because of the resistance, some of the gates actually have a lower voltage, but still it's around 5,000 volts. It is very low amperage, though, between 100 and 150 milliamps, and it's of pulsing nature. The low amps in combination with the pulsing nature makes that it is not deadly despite the high voltage. Not deadly to people, not deadly to other large mammals. There are three types of gates that we have at this melon patch. On the upper left, we see a swing gate. It has electrified wires installed at three different heights on this gate. We have two locations with a bump gate on the lower left. And these horizontal poles are fiberglass, partially fiberglass, and have electrified strings hanging down. This is a standard application from the cattle industry. And when you have a truck, farm equipment, you simply bump against these horizontal beams, and they're on a spring mechanism, and they can swing open and automatically close behind you. So you do not have to get out of the vehicle to open, back in, drive through, get out, close the gate, back in your vehicle. It's very simple. It's a drive-through application. The same is true for the drive over wires, and that's on the lower right. It's kind of hard to see in this image, but between the two white planks, there are metal wires a few inches above the ground. And you can drive over this with a truck, but if you've got big feet, like humans or a bear, you will hit the wires when you try to walk over it, and you will be shocked. So these are the three treatments that we have. Now, the preliminary results, first the swing gate. This is all preliminary based on a rough calculation. There will be final data available after we've gone through the data in a consistent manner. But I can already give you these preliminary results. We've had about 20 black bear approach the swing gate. There have been 0 passes by black bears across the swing gate. So basically, the effectiveness as a barrier is 100% so far. So that's quite good news. The bump gates, there were 2 locations equipped with these bump gates. They performed far less. As you can see by the image in the lower right, there's a black bear that simply walks in between the strands that hang down. Now, these strands are electrified, but it seems that the attractiveness of the melons is high, very high, because they've been exposed to it for many years prior. In addition, it seems that these vertical strands are very easy to walk in between, and the wires kind of slide on the side of their fur, and perhaps their fur provides some sort of insulation from the shock. We were not happy with this performance because about 30 bears passed out of the 50 that approached in front of that one gate. So that's not very good. Now, don't be mistaken, though. It's not that the bears don't notice. It's not that the barrier effect is 0. As is illustrated by this one bear that leans against the wooden post that is not conductive, and he glances to the corn, and behind the corn is where the melons are. So this bear is really trying to figure out, how do I get to the corn? How do I get to the melons without being shocked? Here's a series of images of a black bear leaving the melon patch with a melon in its mouth. On the image on the upper right, you see that one of the strands is actually on the nose of the bear. Now, this is, of course, an extremely sensitive part of the body of the animal. And if you look at the image on the lower left, you will see that indeed a shock was delivered, and the bear jumped and dropped the melon in place. So just as an illustration that the barrier effect is not 0. It was just not good enough, in our opinion. What is important to realize is that none of the barriers tested are a barrier for ungulates. They simply do not have the height. This is illustrated by mule deer that can easily jump from standing position the height of these gates. So bear in mind that we really focused on species with paws, specifically black bear, on this study. Now, we made some modifications to this gate. The first modification was we needed to be certain that the electricity was on, because when the farmer would walk through, or the employees of the farmer would walk through, sometimes they would forget to switch the electricity back on. Essentially what happened is the farmer said, I'm going to tape everything permanently on. and that's illustrated by the black tape on the far post that you can see in the image on the upper right. We now knew for certain that the electricity was always on. And by the way, each field visit, we also took voltage readings to make sure that there was no leak and that the voltage was indeed, electricity was indeed switched on. In addition, what we did, we attached a net to the vertical strands hanging down from the fiberglass poles. This net also has metal wires weaved into it. It is also conductive. So when the bear touches the vertical strands or anything of the net, it will get shocked. The advantage of the net is that you now cannot simply walk in between the vertical strands. You basically have to put your head kind of under the netting, and the entire netting will be on the head and then on the body of the bear as it would attempt to walk through. So there's much longer contact and much more contact with the bear if they would walk through. Now, since this modification, we've had extremely good results. About 15 black bear approached since this modification, and we've had 0 passages since then. So this seems to have been a critical modification to this commercially available design to make it suitable and effective to keep black bears out of, in this case, a melon patch. The third design, actually the first time I've seen this is in South Africa in game reserves. We've got lions and leopards and such, worked quite well. There's been one passage of a black bear out of about 30 approaches. After that passage happened, we could see what the bear did. It carefully put its feet in between 2 sets of wires, made its way to one of the insulating white boards on the side, and then balanced itself on that white board as it made its way into the melon patch. Since then, together with people and carnivores, we've put the wires at a closer distance. So it would be harder for a bear to carefully position their feet in between the wires. Since then, 0 bears have been able to pass. Now, this type of barrier is not a barrier to ungulates. We see this with elk in this case, but also with white-tailed deer. They carefully place their feet in between the wires, and in some cases, presumably because they're shocked, they will also run across it. So again, it is a measure that is suited for species like bears, but not for the ungulate. Now, just as a side note, we also noticed, because of worn paths, that bears were accessing the melon patch by crawling underneath the fence. And we set cameras in strategic locations. What we found is that they were actually accessing the patch by crawling underneath the bottom wire. And it leads to funny scenes where it almost looks like an up dog position in yoga. Now, as the bears got more and more habituated to the melons, they also started digging under the fence. This is visible in this image here. You can even see a broken melon right next to where the bears are accessing the field. Now, together with people and carnivores, we did several things. We lowered the wire, first the bottom wire, to make it closer to the ground and harder to crawl underneath. The fence design, as it was original, had the second wire from the bottom be a ground. That wire was now also made hot, so that the bears would also be shocked when they touched that second wire. That was still not sufficient. A light scare, motion-activated light scare, flashing light, was hung at select locations. That didn't do anything, but a motion-activated sound scare seemed to have kept the bears from approaching this location. We've had basically 0 bears attempt to crawl underneath the fence at that location where this motion-activated sound alarm was installed. But that's, of course, a spot treatment, and it doesn't necessarily affect the barrier for the entire length of the fence. It's a real problem spot treatment. And just some of the examples with regard to the creativity of these bears. You can again see upper left, a bear leaving the field with a melon. And apparently it kind of kicks that melon with a delay factor. After the bear has crossed the fence, slowly the melon rolls its way and picks it up and moves away. So don't ever underestimate bears as to what they're capable of. Now, preliminary conclusions. After modifications, these gates are a very good barrier, nearly 100% for the 3 barrier types for bears. And compared to the surrounding, the electric fence surrounding the melon patch, they are at least as good and actually even better than the electrified fence. So this is quite promising. It allowed us to test the barrier effect of these experimental things in a controlled setting. And it seems that we might be able to move on to a publicly accessible location along a real highway. Now, with regard to the farmer's perspective, the farmer reported about 80% reduction in melons lost to bears. Now, this is an estimate, it's not a measurement, but the farmer is the stakeholder here, and it's quite encouraging. I think that when we enter our second season next year, that we can do better, because now we've made the gates a more functional barrier, specifically the bump gates. So it will be harder for bears to access. And if they access, they will likely cross under the fence at select locations rather than through the gates. We also found that these barriers are not a barrier to ungulates. So if we implement these types of measures along real highways, it has to be seen, these electrified barriers, as an additional measure to what you would do for ungulates. And when I'm thinking about additional the basic measure for ungulates, it is the wildlife guards. We know that they can be a substantial barrier for ungulates. They have poor performance for species with paws, but that is where the electrified barriers may come in. As a side note, the melon patch and the mitigation measures there were briefly featured in 60 Minutes on CBS News about a week ago. They specifically interviewed Bryce Andrews, who works with people and carnivores. And the 60-minute interview was really about grizzly bears in general, rather than black bears and highways in specific. Last part of the presentation, the jump outs. Jump outs allow animals to escape from a fenced road corridor. The animals should not be inside the fenced road corridor, but it inevitably happens. When it happens, they have to be able to leave. The jump outs allow the animals to walk up to the height of the fence. The height of these jump outs should be low enough that animals readily jump out, and should be high enough that animals do not jump into the fenced road corridor. So there's a balance there. Now, what we found by placing cameras in the past at 10 jump outs along Highway 93 North in Montana is that the use of these jump outs was actually quite low, very low for white-tailed deer, about 7%, and around 32% for mule deer. Now, the reason I put a scale up to 100% in this graph is, well, we want animals to jump down to the safe side of the fence. We want it to be at or near 100%. And by putting the scale in place, it shows you how poor the use is of these jump outs. And this is important because most of the deer that show up on these jump outs do not jump down. They move to another jump out. Perhaps they move out there, they jump down there, or they move to a fence end, or they're hit by traffic. So what we need to do is make these jump outs be used more readily by the deer. It seems that we have some margin to play with. The height of these jump outs is around 6.5 feet in some locations, because there's, at least in the period that we monitored with the cameras, there were no deer jumping up into the fenced road corridor. Now, what do we propose? We propose to select the same 10 jump outs, 6 of them in an area where we know there's predominantly white-tailed deer, and 4 in an area with predominantly mule deer. By making modifications to the jump outs in these areas, we hopefully will be able to gather information on the suitability of the jump outs for white-tailed deer as well as mule deer, rather than only one of the 2 species. Now, what we will do, we will reduce the height of the jump outs to about 5 to 5.5 feet. The final decision will be made in collaboration with the stakeholders, Montana Department of Transportation, and the Confederated Salish and Kootenai tribes. We will also put a bar on the top of the jump out, as is illustrated on the image on the right. Now, what does this do? Animals that are on top of the jump out can step over that bar and take advantage of the lower height and more readily jump down to the safe side of the fence. But if you're an animal at the bottom of this jump out, there's not enough room to land in front of the bar. You also have to clear the bar. That means that we can keep the effective height for animals that want to jump up into the road corridor the same, meaning around 6 or 6.5 feet or so. So by having this bar added, we hope that we do not increase the risk of wildlife vehicle collisions, but rather reduce it by allowing animals to easily and readily escape the fence road corridor. And what is the status on this? We're waiting for approval and agreement by the Montana Department of Transportation. We already have obtained a research permit from the Confederated Salish and Kootenai tribes, and I hope to have this agreement in place again by the end of next week. It's tied in with what we are doing for Montana Department of Transportation with the 2 locations along Highway 93 at which electrified barriers will be installed. Another question, is the bar the only modification you're trying? No, it is a combination of lowering the height and adding the bars to the jump out. So it's a combination, making it more easy for the animals to readily jump out of the fenced right-of-way, and at the same time, do not make it any easier for animals to jump up by having that bar attached. Question from Trevor, do we anticipate any increasing wrong way travel by carnivores with reduced height? I'm assuming this is about the jump outs. It's kind of hard to say. I do not know. The wall itself will be lower, and then there will be a space and then a bar. So if you're not jumping but climbing, then perhaps you can take advantage of a lower height. One of the things I would suggest in general for jump outs, the face of the jump outs, the wall of the jump outs in general, is to make it smooth. This has been done in Banff for many, many years already, attaching metal plates to the front, the wall of the jump outs, so that species that climb do not get a foothold, literally. So that is the only thing I can say, but I do not know if the overall reduced height allows them to basically pull themselves up. Predator use, carnivore use of the jump outs has been extremely low in the past, in my experience. So it will be an incident rather than a pattern, I assume. One more question. Black bears and cougars. Yep. With regard to the jump outs, yeah, I think about the same animals. Cougars, that's even tougher than black bears. Cougars can easily jump the height of the fence to begin with, and if you have wooden posts, then it's already a problem. And that also counts for black bears. They can easily climb those wooden poles if they really want to. So a standard wildlife fence in the West, if you use wooden posts, is not a barrier for black bears, not a barrier for cougars. Metal posts and potentially overhangs on top of the fence need to be implemented if you are really targeting black bears or cougars.
Hi, Marcel. It's Jeremy Guck here. Just a quick question that others may know, but I don't, is have there been any other studies done on these jump outs? I'm a bit startled with how ineffective they are.
Yes, there have been studies done, but I think that the emphasis has been on just building them and believing it works. And it is indeed shocking to me that the effectiveness is stunningly low. We also do not necessarily have an alternative. So I think the best way forward is to figure out how to make them more effective in allowing animals to escape from the fence right of way, and at the same time uh, keep it difficult for animals to jump up into the fence road corridor. But that is why we're doing this, because I think we need to do it. Too many people just build these wildlife jump outs, assume they work, whereas it seems they do not work nearly as well as we would like to.